Vehicle Challenge continues at the U.S. Space and Rocket Center here in Huntsville, Alabama, home to Space Camp and the official visitor center for the Marshall Space Flight Center. And we're now joined by Garrett, who's with the California State Polytechnical University of Pomona, better known as Cal Poly, I think, is probably how everybody else back home would call it, right?
Yeah, that's way too long of a name, but it works.
All right, so we've got your team here doing some last-minute cleanup and touch-ups on your design here for your rocket. Looks very nice. Everything's looking pretty good. Tell us about how you arrived at this particular design for the retrieval system.
Now, actually, the individual hunched down right here, Chow Wang, he put so much work. Him and I actually were flipping through a lot of linkage books for mechanical arms, and eventually, using both of our 3D printers, we were able to come up with that design.
I was about to say, these obviously you can tell that's some 3D printed with different colors, school colors in some cases. You actually have your own 3D printer, or is it the school's?
Both of us have one. So
that's
we have
really
two.
Cool.
Yeah, they're a lot of fun, and the price is becoming, a lot more accessible.
So then, I see you've also got a little bit of a carbon fiber base for it there.
Yeah, it's 2 layers of carbon fiber, and then a layer of aeromat, another layer of carbon fiber, aeromat, and then 2 more.
So it looks like the way that you have this one planned to use is it's going to acquire a sample and go up this slide. Is that right?
Yeah, we got that idea from my 3D printer, which has a ball screw to raise the Z position. So we decided to use that, but at a slight angle to raise the platform.
All right, looks like you're. Let's step out of the way here, and we'll come over here to this side. It looks like we're about ready to go. The sample is in place. I couldn't help but notice that you've actually got a guitar pedal here.
Yeah, that's our controller switch. Oh, ciao.
Whenever you're ready. Yep. Very cool.
Yeah. It's a good way to use an old piece of machinery that was laying around. Or electronics, that is.
So, is there any added, what was it, as far as facing the challenge again to get this to be kind of like a screw elevator to move it up, as opposed to bringing the rocket itself closer to the ground? Is this just helpful when it comes to then standing it upright?
Yeah.
Okay.
Having it raised above the ground like this makes it so that when the pivot occurs, we can have the CG right where we need it to be, and that way we don't need as much force on the motor.
Center of gravity.
Yeah, exactly. So that's why that tiny little electric motor that you're seeing just has a series of gearboxes, and it's able to raise this entire assembly.
And I see here what looks like essentially bicycle chain there, and a few gears on it.
Yep. The bicycle chain is connected to a 60-to-1 gearbox, and then that's connected to a small electric motor with its own small gearbox.
Oh, they're inviting the judges there to take a close look at the computer printout, or readout, I should say. It's up and looks like we're ready to go.
Yep.
So it is all based on spacing, or does it have a detection module on it?
The detection module isn't being used today. We're hoping to have it ready during the rocket fair so that we can show it off, but it sadly wasn't ready for today. But originally it had a computer vision system in order to detect the payload, but we'll have it up and running.
It looks like, if I'm not mistaken, except for the wires and some of the metal work, as far as this nuts and bolts, most of that is 3D printed.
Yeah, almost the entire thing is 3D printed.
That's fantastic.
Yeah, that way, if anything breaks, if we want to change something, we can just have it ready within 20 hours at max. But yeah, it just made it a lot easier for production, especially when you have 2 of them. But yeah.
So a nice steady ascent there for your retrieval unit.
Yeah, it gets a little bit wobbly towards the top because of even the smallest bit of off-centering with that ball screw. It'll start to oscillate, and you'll see that as it reaches towards the top. But this is going to be a really long process.
So since we've got some time, now would be a good time for you to tell us a little bit about your teammates.
Yeah. Okay, so the majority of the team, we actually met during orientation day, which is funny because we're all transfer students from we're all from a community college not too far from Cal Poly, so.
And all of you transferred into Cal Poly.
Yeah. all of us transferred to. 3 of us went to the same community college, and I actually went to high school with one of them, and I didn't even know that. But yeah, but here we are today, and it's really just a group of friends.
So you're all homegrown then, out there in California?
Yes, sir.
Very cool. What kind of backgrounds does everyone have?
Everyone? Well, it's actually a split group. We have, right now, a total of 11 aerospace engineering majors, and then 5 ECET, which is electrical and computer engineering technical, for their major. We picked them up to help with the robotics and a lot of the programming and electronics.
Well, so far so good, and it looks pretty steady, but I don't want to jinx it just yet, so we'll move on. What was the more challenging aspects of this whole design that you felt was something you had to overcome?
Well, there was a lot of prototyping with different types of filament for our 3D printers, and one actually broke my 3D printer because, it had carbon fiber filaments in it, or carbon fiber shreds in it, and I actually grinded through my nozzle.
Oh, no.
So, yeah. Sorry, it's hard to this is the big moment right here for us.
So we can see the oscillation you were talking about before.
Yeah.
But we also see the line that it needs to get to.
Yeah, and just watch how perfectly it really hits that position. It's pretty fantastic, the positioning of the limit switch. And the limit switch, which is on the other side, that's actually mounted using a small 3D printed L bracket. So, just makes production and prototyping so much faster.
All right, looks like it hit that switch just fine. We saw that everybody was frantically working on this before we actually went on the air. What was everyone doing?
The wiring setup with the terminals, we believe that a couple of them were switched during the reassembly of the entire electronics control station. So we were really nervous about that. Sorry.
You were there for a second?
Yeah. I was trying my hardest to pay attention, but...
Well, that's okay. Everybody was wondering. Oh, no. There you go.
Ooh. Okay.
You got some happy. Are you okay? You're gonna fall out?
Good. That was nervous. We've never bent the arm like that, so.
Yeah, it looks like I'm looking around at a few of your teammates, especially back in there. They're all gasping for breath. So glad that they've got through. All right, well, we're not done yet.
Because PLA, this isn't ABS, by the way. It's PLA plastic, which is a lot more brittle. But it does that if the tension isn't taken care of perfectly right away. There we go.
Okay, now we got the insertion.
Yep.
Oh, it did? Yeah. Okay.
So it inserted quickly.
Yeah.
All right.
It's a fast one.
5 minutes, almost on the dot.
So 5 minutes on the dot?
5 minutes to the second. Nice.
Excellent.
So a little over 5 minutes.
Yeah.
All right, so now the moment of truth is to make sure it goes to 85 degrees.
Yes, sir.
All right, so that's got to be a load off your mind.
Oh, yeah. I'm feeling a lot better now. Yeah, exactly. That was stressful.
Well, that's fantastic. Obviously, you guys became a tight-knit group.
It's ridiculous. I definitely consider a lot of these members like very close friends, if not all of them. Like, of course, we've been through a lot, and yeah, they're great. They're a great bunch of people.
So I know this. I don't mean to treat that lightly, because I mean, being able to carry this group of friends with you as you come close to graduation, that kind of thing is very important. But what other things do you think you're going to carry past graduation into your next career?
Past graduation, this year I've gone through team lead, or I've been team lead this year, and it was a lot different than I expected.
How so?
It's stressful, which I expected, but it was more so like emotional and making sure that everyone's feelings, and also, I don't know, there's a lot more interpersonal communication tied into it than I had initially thought. So I think that I definitely gained that and developed that from it. And I don't think I would have gotten that anywhere else in the competition. So I'm very thankful to have that opportunity.
So that collaborative process really work on that part.
Yeah, basically when you're coming up with designs and you need to discuss which might be the best design, and you have to sometimes tell someone that their design isn't exact, it's kind of hard, especially when you really care about the person. So, but it works out.
Yeah, the results can't be denied. Looks like so far a successful run so far.
So far, yeah. But yeah.
So it looks like one of our judges over there is going to have one of your taller members of your team go ahead and do the. He's going to do the multiple measurements of the length of the rocket. I believe they'll end up taking the average to make sure it's at that 85 degrees. What would you say is the most that tipping point, that crucial development that you knew? Okay, this is where it's going to hinge, and if this is successful, I don't mean necessarily today, but during the whole development process.
Honestly, it might have been. Well, it's a combination between the arm and the actual lifting system of the rocket, because we've never worked with bicycle chains, which sounds like, well, I have, but I haven't installed one on something that was made from scratch.
Oh, sure, attaching one to your Huffy and as opposed to attaching one on here, totally different.
So that was definitely different to us, to make sure that both sprockets were aligned. We found out how much that can impact the motion of it, as well as the tension on the spring. As you saw, there was that jerk at the bottom. What it was the tension was switching from one side to the other. So it had a tension on one side of the sprockets, and it switched over, and that's what caused that jerk. But yeah, that's hard to accommodate for.
Yeah, I think the entire room held their collective breaths on that one.
Well, we've seen it before, so we were kind of like, just pretty used to it. It does that.
So have you, when you test flew your rocket, was it on this particular rig?
No, we actually, the place which we launched it from, they feel most comfortable if we use their launch rails. So,
okay.
Yeah.
So what about on Saturday?
I'm sorry?
What about on Saturday?
We could launch off of this. I don't want to really damage the arm. I mean, it's made, if it were an actual Mars Ascent vehicle, it would be shielded, the arm that is, from the exhaust of the motor, but also because it's 3D printed, it makes it so that if it is damaged or destroyed, it can be easily replicated. So
yeah, rapid prototyping is amazing, isn't it?
Yes, and if we end up having a settlement on Mars, then of course rapid prototyping will be on there.
All right, here's the moment of truth. Justin's beginning the measurements to make sure it went to at least 85 degrees.
As you can see, the fins and nose fin are 3D printed as well. So our 3D printer went through a lot of work.
But it looks stellar.
I'm hearing 84.
All right, 84.7 is what we're hearing over here, and I think they round up. Don't quote me on that.
They do. That one was 83.7 though.
You kind of want to lean it back towards you a little bit.
Yeah. Just pushing it, and then suddenly we're way up. It's got to be hard for Justin.
He doesn't want to lean on it, yeah.
Did you hear that?
I didn't hear it either, I'm sorry. Well, we know at least one of them came at least within that 85 range, so that's the good news. All right, we'll have to see what the judges say, but I think all in all, though, you're successful in a lot of in most of it, at least that we can tell so far. So, congratulations on that.
Thank you so much. I really appreciate it.
And we look forward to you and your team flying on Saturday. And we'll talk to you then about your rocket. Okay?
Good. I'll see you then.
This is Garrett from Cal Poly out of Pomona, California. Just another one of the successful teams that we've had here at the Mars Ascent Vehicle Challenge. We've got a few more teams left before we close out our day, so stay with us.